Um, I think we should start. I kind of think we should start because we've got a lot of stuff to cover. And I know people will be filtering in, but let's see if we can let's see if we can get the show running. I know it's the last show before drinks, and I'll try not to keep you here out of your drinking time. But it's probably going to happen, right? Okay, so before we begin, because I'm worried that I'm not going to get through all of this in time, and at the very last slide, I do have a URL where you can find some interesting stuff. But you know, if I don't get to the last slide, then you never see the URL. So I put it on the first slide. You can look at this tool that we're going to show here today at www.sensepost.com/research-blah. And then at Amsterdam, the Black Hat briefings in Amsterdam, I promised that we'll be giving out the release of EOR, which is a very nice web application scanner. That's now just being released as well, so it's sitting there in research EOR. And then again, I suspect that this might run a little bit late, but I'll do my best to fit it in, so I'm going to move straight along. Okay, so at Sensepost, we do a lot of external assessments, which is basically breaking into a network over the internet. It's one of the core focuses of the business. And we've done it many times. Hello. So you would also know that the people that was on the course, in our bootcamp classes, that we have a strong methodology that we follow when we do this. So what I started doing is looking at a way that we can possibly automate parts of this methodology, and seeing which parts of the methodology we can really automate, which parts of the methodology automates well, which parts are really difficult to automate, and why they fall apart, and if there's something we can do in that process to make it work better. So if you want to automate something, you need to really understand how it works, right? In order to automate something, we have to create a machine. A machine we need to code, and in order to code it, we need to have some kind of algorithm that we can code it by. In order to build an algorithm, we need to be able to write it down on a piece of paper and say, this is exactly what we're going to be doing. And in order to write it down on a piece of paper, we need to have done it a couple of times, which we have done, so hopefully this will work. If you can't write it down on paper exactly what it is that you would want to do in a kind of algorithmic flow, then you probably don't understand it exactly, okay? If you can write something down in a flow or in a block chart kind of thing, then you probably know exactly what's going on. So where does this whole thing fall apart? It falls apart with exceptions. So exceptions within a process is always the root of all evil. And you get the situation where you say, this works like this, and we can do this, except when, you know, x equals 5. Because if x equals 5, then we have to apply a whole new set of rules. And that's the thing that bites you when you want to automate something. And you'll see throughout this presentation that the parts that has exceptions in there, those are the parts that is really difficult to automate. However, what we can do is say, well, let's do a trade-off. You know, if it works 99.99% of the time, and it's going to take me 3 months to code that exception, then we'll live with it. And then we'll say there's an exception, we know about the exception, but we'll live with it. Okay, then I want to quickly talk about weird perceptions that's kind of in the industry. If you speak to a lot of people, not necessarily here at Black Hat, but for sure at DEF CON, they would tell you, oh, Windows sucks, you know, Windows sucks, and Windows sucks. And Unix is so cool, and Unix is so cool. And Unix is so cool, right? And Windows is perhaps sometimes not that, you know, nice, but let me tell you that we kind of have this perception that says Windows usually have GUI applications on top of there, And we prefer command line applications, right? And the thing is, the problem that we have with GUI tools is that people kind of think that because we have a GUI tool, we need to dumb this thing down so that silly users can use this. I'm saying that is a problem of the person that's implementing the GUI and not of the GUI or of the operating system itself. Okay? So you can still make a GUI that is really functional and that's really flexible without having to make it into a command line tool. With the Unix command line tools, we see that the stuff is mostly, fire and forget stuff. You run an nmap, and there we go. The nmap is kicked off. You pipe it to a file. You run a tail -f on the file, and you can see what's happening. But it doesn't tell you, okay, we're now 50% done, and the next host we're going to scan is this one. It's a little bit difficult. The Unix command line tools, because they, Unix command line tools are not interactive either. People kind of prefer to work in Unix with command line tools because it's difficult to write X11 interfaces. Now what we do is the BD-blah actually uses what we call hot text boxes. So it's really a question of making it as accessible to the end user as possible, so that the user can copy and paste the stuff, or you can run it through a grep or a sed, or he can do with it exactly what he wants to do. We don't have a database back into this stuff, so if you make a change in the text box, you've changed the data right there, and it makes it really flexible in terms of use. Okay, so what we're going to do is we're going to show you a couple of demos of this thing. And the problem that we have is the tool is really built for attacks, right? It's and just to clear up something here, if the difference between an attack and an assessment is a very fine line. And it really depends if it's your IP address or your domain that you're putting in there, or someone else's domain or IP address, then it becomes an attack. It's really built for very large networks. And the problem is at Sensepost, we don't have a very large network. But our clients kind of do. But we can't show them. We can't show you their network, right? We can't run live scans here on their network. We don't want to do that because they won't appreciate it. And if you were a client, you wouldn't appreciate it if we run it at Black Hat scan on your network, right? So what we're going to do is on the passive side of things, where we're not sending packets into the network, we're going to look at IBM and Playboy. And where we're going active is on the Sensepost network and on VMware servers. Now, I didn't want to do it live here, actually run the scan, because it's a little bit risky. You never know what you're going to get back, right? And they just might pop out something that's kind of unexpected. So what we've done is we've built little videos of the process, and then I'm going to show you. And those videos are actually exactly how the tool looks. But in some places, it has been time-lapse. So, when something takes half an hour to run, we're not going to have you sit here for half an hour looking at the screen. I'm simply going to pause that thing, wait until it's done, and show you the end result. But it is exactly the way that the tool operates, and we can maybe play around with it afterwards. Now, if you look at our external methodology, our methodology for doing external assessments, you'll see that it's basically broken up into 5 phases. First is a footprint, then a fingerprint, doing proper targeting of your target, vulnerability discovery, and at the end of the day, penetration testing. And what I'm going to do is I'm going to take the first part here, which is the footprint, and I'm going to expand that into this. Okay, this is actually how the footprint is working. So what we do is we find domains, and people that's been on bootcamp, this should be old news to you, and I'm not going to go into exactly how the methodology works in every step of it. But we find domains, right? From these domains, we find subdomains, if they're subdomains. From the subdomains and the domains, we find all the forward DNS entries that we can possibly find. Those forward DNS entries points us to IP numbers, right? And if you look up www.blackhat.com, that points to an IP number. That IP number is then expanded into a net block, and that net block might be, one IP address. It might be 13. It might be 16 IP addresses, 32. It might be a class C. It might even be a class A, right? It all depends on the definition of that network. Once we have the net blocks, we basically do a reverse scan, a reverse DNS scan of the entire block that we've defined. And doing the reverse scan of the block, we're going to find new domains that we're going to put back into the first step. And we also will find out if or not net block definitions are actually correct. Because if we see a lot of stuff in reverse DNS coming back that clearly doesn't belong to the target, then it means our definition of our net block is wrong. And once we have our net blocks nicely defined, we're going to go on and we're going to do vitality testing. Vitality testing basically just means we're going to find out if a machine is alive in that network or not. And that's the footprinting methodology, right? The end result of this is a list of IP addresses that is accessible of a target over the internet. We'll touch on this just a little bit later on again. Now, I've got a little video thingy that I've built in Word, okay, of how this process works. So I'm going to try and play it. If I can find my mouse, there we go. Okay, so we start off with the main domain. The main domain gives us subdomains. Once we have the subdomains, we basically find forward DNS entries, and all those little arrows points to IP addresses. We then start putting those IP addresses within blocks, and like you see there, oh shit, sorry, no. Okay, I'll try that again. Subdomains, forwards, right. Okay, yes. Okay, and it goes into the blocks. What you can see here is that the IP over there, that's just one IP. It's a block that contains, this is one single IP address, right? It could be large blocks, it could be small blocks. From there, what we do is we basically find all the reverse DNS entries in there. That's just the block definitions that we've done there, just saying, okay, this is our initial block definitions. We do reverse DNS scans, and we might find a new, totally unrelated domain, which means our definition of this block wasn't correct. We might find a new related domain, all right? And we have to follow the process then again. Okay, and from there, what we're going to do from there is we're basically going to start doing vitality scanning, or in this case, you see that we define these blocks a little bit more smaller, making sure that the block definitions are exactly correct. We then do vitality scanning, which is these little blocks, these little round circles. They are actually just O's in there. That says these are the IP numbers that are actually alive within this network. And once we found those, we're going to do a complete port scan of it to say, these are all the ports that are open on these IP addresses that we found. Once we have the ports open, we can now go to the next step and say, well, on that port 80, there's a vulnerability. Let's say Apache 132 chunk encoding problem on that IP address. And that's basically the methodology, right? Okay. Now, the first part, if I just go back, is finding the domains. Now, finding the domains is not an easy thing. 2 years ago, I think it was 2 years ago, Charles? 2 years ago, we did a presentation in Singapore and Amsterdam on finding domains and non-obvious relationship between domains. And that it goes a little bit like this, but we haven't built it yet. So it's something that we're still working on. And because time is short, I'm not going to go through it right now. Let's assume for now that we do have a domain, right? And what we want to do is we want to find subdomains. Now, how do you find a subdomain? There's a really easy way to do that is if you, let's say you want to find a subdomain for IBM, right? If you Google for IBM and you get a hit that sits on www.chess.ibm.com, you know that the subdomain chess.ibm.com exists, right? And you can do this with a couple of words, keywords, and a couple of Google queries. You can actually find a lot of domains that sits in there. The other thing that you find there is you know that www.chess.ibm.com exists. So that's one of the forward entries that you don't have to do. It's a forward domain lookup that already you can resolve into an IP address. You know that it exists. You'll see how we do that later on. Okay, so we basically do this. If we see that there's a, if the result that we're getting back from Google actually contains the main domain name, then we can say it's part of the subdomain, like www.chess.ibm.com contains the word ibm.com, so it must be a subdomain, right? So what I'm going to do now is I'm going to quickly show you a little video of how this works within BDBLA. Now, it takes about 5 minutes to do, to run through this. You can set it up. If you want to set it up so that there's, Google returns, 100 pages, then that's cool. You can do that. In this case, I set it up so that it only returns 3 pages at a time, and with about 7 keywords. So let's have a look and see how this thing runs. Okay, so I put in there the name IBM.com. Can everyone see there? Kind of, right? I click on Start, and you see at the bottom it starts doing the Google queries. We find, and the one thing that's important, we find email addresses in this thing as well. And from email addresses, we can also get subdomains. So this guy is, for instance, No Jan, you're not here today, are you? Okay, nojan@us.ibm.com. Now, well, from there, we can know that there's a subdomain, us.ibm.com, right? It's clear as daylight. And we can see that within the first hit, we get a couple of subdomains in here, alphaworks.ibm.com, chess.ibm.com, Europe, Olympic, patents, printers, and basically I've stopped it there and I've just showed you the full result at the end. So this is all the subdomains that we can mine, and it takes about 5 minutes to get all those subdomains out there, right? It worked kind of cool. What we want to do with those subdomains is go in the methodology. We want to now do the forward entries, right? So within the forward entries, what we're going to do is we're going to say we start with the domains or the subdomains. We're going to get the MX and the NS records for those domains or subdomains. We're going to check if a zone transfer is possible on that zone. If a zone transfer is possible, it means we get the entire zone immediately, and we don't have to test for any of the other names, right? But beyond that, what we actually need to do is we need to do some kind of brute forcing. The way that we do the brute forcing is we have a collection of lists, right? So let's say, let me ask you this. If I know that a machine exists called Gandalf.ibm.com, what's the chances that a machine called Frodo.ibm.com is going to exist as well? Pretty good, hey? Okay, so what do is we have these lists of names. It's trees. We have trees in there. We have characters out of Hitchhiker's Guide to the Galaxy. We have characters out of Lords of the Rings. We have all of these kind of lists, and you can put as many lists as you want in there. And basically what we do is we put the most popular characters or the most popular names first in the list. We check for the first 4, and that's configurable, names, and if they exist, we say, any of those names exist, we say, okay, that's this naming schema that these people are using, and we check the entire list. We don't check the entire list from scratch, because what's the chances that they're going to have a, whatever, you know, what's a character out of Lords of the Rings that you don't know about? Well, I don't know. What's the chances that they're going to have a Krikrimakwanku.ibm.com, which when Krikrimakwanku is now, let's say, a character of the Lords of the Rings, and they won't have a Gandalf. They're going to have a Gandalf, right? Okay, you get the idea, right? Okay, so let's see. So let's see how this is working on Playboy.com. This is now, I've done the first step, which is the subdomains, and in the subdomains with Playboy, I only found casino.playboy.com and playboynet.playboy.com. A couple of email addresses you can, you know, if you want to take notes, I don't know. And we now basically go to the forwards tab there, okay, click, there we go. And we import those domains, those subdomains. Oh, sorry, I want to show you this as well. You see these things over here, those names over there? Those are names of Playboy that we already got from our Google search. Like I said, I mean, we know something returned from Google called boards.playboy.com. We know it's a name, we can resolve it, and we already get an IP address. So by now, we already have a list of a couple of names and IP addresses that can be resolved to IP numbers, right? But we want to add to that. So we basically, you know, import the domains that we have, and we click on Start. It's as easy as that. Immediately, you can't see it there, but immediately we get the MX records, the NS records, and it's now basically at the bottom there, you can see it's basically going through a whole lot of different lists. Here we have colors, we have stuff from Discworld, e-commerce, fruit, Greek. I'm gonna F it up again. I always say methodology, but it's what? Mythology. You know, those dudes, you know. We have them in there. We have planets and all of that. And you can see there, we already found a machine called content.playboy.com. I'll basically pause it and just, you know, let it run through the whole thing. And we got stuff like Secure 2 and, you know, pics, which could be interesting, and help and content and all of that. Also, we fuzz that. So if we test for Gandalf, we're going to test for Gandalf 1 and Gandalf 2 and Gandalf-1 and Gandalf-2. And you can configure as many of those fuzzing characters as you wish. All right. So this is what we can get from our forward DNS on playboy.com. That's just about everything we can get on them. You can see there's also stuff from casino.playboy.com. So it doesn't really matter how many domains you put in there. It's going to go through all of them. Okay, and it's going to add all of this to the list. What we want to do next is, you remember in the methodology, we want to now go to the footprinting and we want to define the net blocks. Now, defining the net blocks are actually very difficult to do, okay? Because our first assumption here is that we only have net blocks that comes from IP addresses that has DNS information. But if you look around, you might find that on places like Aaron and Ripe and Apnic and Lacnic and Afrinic and all of those wonderful places, there's a whole lot of other blocks defined for these people as well, right? So we're only looking at stuff that has DNS information. You should actually be looking there as well. And the problem with those registrars are they don't have any standard interface how to query them, and they don't support, well, actually, Aaron support wildcards, and Ripe support wildcards, although I don't think they know they do, but they do. Apnic, you can't do wildcards. Lacnic is, yes? Yeah. Sure. That's important what he's saying. In fact, you can phone them, right? And you can write them letters. You actually have to write them physical letters and put it in a mail thingy and deliver it, right? And you can write them and ask them for their database, and they will actually give you credentials to that FTP server. And we've got a couple of those. But the interface to that stuff is also non-standard, and you don't want to carry around a couple of megs, to pull that stuff out. So that's pretty manually. On the WHOI side, things are also a mess, right? You can't get WHOI's queries properly done on a lot of these registrars. So it's really difficult to do. What we can do is we can start off by saying these IP addresses that we found, we're going to trim them down to class Cs. That's a start. Just as a start, we're going to trim them down as a class C. So we're going to remove the last octet from that IP address. We're going to see what's in that class C, and we put them in as class Cs for now. The idea is that later on we're going to define them. We're going to nicely define them up. The other thing that we can do to find other net blocks is to basically take an IP address, look at what the AS number for that IP address is, right? And then look at other routes that sits in that AS as well. Okay? It actually works okay in some cases. Again, here, the whole thing is, there's an exception here. So Lacnic works, but this doesn't work. And with this AS it works, but with that it doesn't work. So it means it's very, very difficult to automate this properly. We can also look at reverse entries, okay? And from reverse entries, kind of find out this is the block size. But you'll see how it works. We'll show you. So again, on the Playboy stuff, I'm going to run this again. We can now go to the net blocks. We can do an import here. It will tell you there that it is importing the forwards, and it's assuming class Cs, right? And that might be a dangerous assumption, but it's a start. And when we click on the actual net block, it will show you the country where that is in. Interestingly, this is in Gibraltar. And it will show you all the forwards that it can find within that net block, right? Now, what we do is we provide a little WHOIS button over there so that you can quickly, click on it. Almost, I was in doubt there to click on it or not. And if you go up, you'll see that this actually belongs to Playboy. Now, there in the WHOIS information, we get a nice definition of that block. And what we can do now is we can basically take that definition that we have over there, and we can stick it back into this over there and hit the modify button. When we hit modify, it's basically going to suck up these blocks over there as well, because they're part of that large net block that we're defining there, right? Okay. So this is where we start the first round of definition on our net blocks. It's not the final round, but it might be the first round that we're going to do on our net block definitions. Okay, so the next thing we do is we do reverse DNS entries. Now, it looks like a major piece of flowchart there, but it's really easy. When you do a reverse walk of a subnet, what you're going to do is you're going to put a filter in there, right? And if the filter matches a particular word, you're going to say, this belongs to the target. And if it doesn't match that word, we're going to say, well, let's look at it later on. We might investigate it and see if it's interesting to us. Okay? So basically, we start off with the net blocks. We perform a reverse for every IP in the block. We then look if it's in the filter. If it is in the filter, we can do things with it, right? The first thing we can do is we can take it out. We can take actually the domain that's in there, in the entry, we can take it out. And this might result in more domains that we want to look at later on. I'll show you in the video. In the video, everything becomes clear, right? Okay, so let's look at it. On the Playboy site, there's all the forwards that we got. It's now sorted by IP. You'll see there's a button that does that. There's netblock definitions that I've done. And I'm going to go to the reverses, import the blocks again there, and click on start with a filter of, let's say, not playboy.com, because maybe they've got playboy.net as well. So I'm just going to make it Playboy, right? And we start there. Now, it takes a bit of time. It's about 5 minutes per class C that it takes. So I'm not going to go through the whole mission. But what you see here is basically, at the top end of the screen, you see all the matched entries. So those are all names that contains the term Playboy. At the bottom, you see you see names that does not contain the word Playboy, right? And they hosting with level 3, so you see a lot of level 3 stuff coming out of there. Okay? At the bottom, you will see there is a thing called Spice TV and Spice Clips. It doesn't match the word Playboy, so it gets in unmatched additional domains. So I decided here to just kind of quickly investigate that and do a whois on spicetv.com, since it's sitting within a block that belongs to Playboy. So we do a quick whois on Spice TV, and we see that it's for Spice Entertainment, and it's in Chicago, and there's a telephone number, and note the address, right? So when we do a whois on playboy.com, we find that, lo and behold, it's the same place, right? So clearly, Spice TV belongs to Playboy. It doesn't take a rocket scientist to figure that out. Okay. So what we can start doing now is we can start taking those entries that we have over there, right? We can cut down those first bits if we want to, right? And we can take all of these entries. That's the matched additional domain. So that's the subdomains that we didn't know about, or like Playboy Enterprises contains the word Playboy, but we didn't have it as a domain. So we can take all of those domains that we have over there, plus the ones that we have at the bottom, and we can feed it back into the forwards, right? So the process starts again until we end up with a situation where we don't have any more, any new or additional domains that we're interested in. You'll see there's a bug in the program actually. It's case sensitive, so playboy.com didn't match because it was an uppercase. And we'll leave it at that. You get the idea, kind of we collect more domains and we see interesting information as well. The other thing that's also interesting here is that when you then click on the, when you actually then go to the netblock definitions, you can then see, if I do it here, you can then see that the forward and reverses are now displayed at the same time, right? So those are all the reverse entries that we got on that particular netblock over there. And if you look at this one and you look at non-matched entries, so those are entries that does not match the filter, okay? You see there clearly that this is the place where Spice TV and all of that other stuff is being hosted. It's in that block. Okay, so it gives you nice information. The next thing that we want to do now is, now that we have our net blocks defined and our net blocks are nice and tight, we want to start finding out what machines are alive in those blocks, because you're sitting with a class B. You're not going to like Nessa scan a complete class B. You're not going to even nmap that, right? That's just silly. What we want to do is we want to find out which machines in those blocks are actually alive, and we can do it in 3 ways. We can do it with ICMP scans. We can do it with ICMP scans, and we can do it with UDP scans, and we can do it with TCP scans. When we do it with UDP or TCP scans, we actually don't want to test all the ports, right? We only want to test a handful of ports, and depending on how much time we have, we want to add ports in there, right? Okay, so what we've built is we've built an asynchronous port scanner into this thing. Now, asynchronous port scanner is really not that difficult to understand how it works. It basically have the speaker and the listener in 2 different processes, okay? So what we're doing is, on the one hand, we're sending out SYNs, and we're sending out SYNs as fast as we want. And on the other side, we have a sniffer, and the sniffer says, is the packet that it's receiving from the correct source port? And if it is from the correct source port, does it have the SYNAC flag set? If it does, it's open, right? If it it's got the reset flag set, then it's closed. And this is just two processes that's running at the same time. It makes it really, really fast. So let's see how that happens. We basically, we can do 2 minutes per port per class B on this thing, right? So it means for every port that you're scanning, let's say you're only scanning port 80, it takes you 2 minutes to scan a port class B. You scan 2 ports, it takes you 4 minutes, and so forth, and so on. Okay, whoops, I missed the video. Right, so what we're doing is, I'm going to show you on sensepost.com the whole thing. Here's the forwards. Okay, it comes in really quick. You can see there at the bottom how quick that thing is coming in, right? I think it was cached, to be honest. We basically pull in the blocks. Interestingly enough, we have something there in 10.15.10, which is in our DNS, thanks to, that we're going to take out, okay? And I'm just basically on this thing going to say, let's, on those 3 class C's that we have over there, let's send it out, and we can basically test for ports in there, and you can select which ports you want to test for. It's totally configurable. You can have as many ports as you want, or ranges, or that kind of thing. The reason why we have to bind a driver here is because Windows, Service Pack 2 breaks raw socket sending. So we had to drop a level lower, and now we're working on an Ethernet layer. And you can see there the speed at which is coming in there at the bottom. It basically shows you if the port is open. You can select if you want to see closed ports as well. I didn't do it in this case. And you get the IP number, and you get the port, and the number at the end is the TTL, which is just interesting to see. And you can see it's going to go into the 72 net just now, which has a lot of machines open, and then you can see how quick it's actually updating this just about now. There we go. Okay. All right, and I've stopped it here and just basically, no. Okay, there we go. Okay, and so those are all the machines that are open on those networks, on those ports. We're talking 23, 22, 25, and 443. So it's a real quick port scanner. That's the bottom line. Okay, if you put the whole footprinting methodology, because we're now done with footprinting, right? We got the IPs that we're interested in from the domain. If you look at the entire process, it looks a bit like that. Now, I don't suspect that you can read that, and I don't actually care, but you can... Now, that came out wrong. Actually, no. What I was trying to say, there's this language barrier thing. What I was trying to say is you don't need to see that, right? The idea with this slide was just to show you that you can go from the top there, it doesn't even show, from a domain all the way down to a list of IP addresses, right? This is that whole picture, just all of the little flowcharts put together. It looks like this. All right. Okay. Okay. So automation, the footprint automation is now done, luckily. Okay, because people, I don't know why, but they don't find it very interesting. Which steps are really difficult to automate? Which steps work? Which are easy? Domain finding is, the part that we haven't implemented. It kind of works, but it's not implemented. You will find that it's really difficult to have that thing 100% correct all the time. It's really difficult to do. I mean, imagine large corporations. They have 1,000, 300, 1,000, 2,000 domains, and finding all of those are really tough. Okay. On the subdomain finding, hey, that's easy, it's done. The forwards, it's easy, it's done. Net blocks, it's difficult. The AES expansion doesn't work for small blocks because if you only have 16 IPs, you don't even have your own AES. So don't try to expand on an AES, it's not going to work. The who's information on those blocks, those small little blocks, is very sketchy. It's flaky. It doesn't actually exist. You do a who's on it, you get the information of the ISP, and it's a class B, and actually it's just 16 IPs. So it's nonsense looking at that. And currently, it's set to manual. Okay, we get a whole lot of that stuff out of reverses as well. I'm going to show you later on how that works. Reverse scan, it's easier, it's done. The vitality scan, it's easier, it's done. However, it's just done for TCP at this stage. To do it for ICMP and UDP is, it's a breeze. It's just implementation time. So just one thing here, a slide that I put in this morning is, why should we actually care about this whole footprinting thing? Well, the thing here is the thinking, the difference in thinking here is that The difference in thinking is finding one vulnerability on one box versus finding the one box with the one vulnerability, right? You'd find that these large corporations, they have machines out there that they don't even know exist. And it's connected to the internal network via VPN. So it is a good thing, TM, to actually find all the machines that this organization would have. Because if you can find a vulnerability on even a low-hanging fruit kind of vulnerability of one of these machines that is sitting in Kazakhstan, and that's connected to the VPN, hey, you're in on the internal network. That's what we want to do, right? Okay, so where are we now? In the whole process, we've done the footprinting, okay? Let's go through the rest of the stuff. The fingerprinting is really tough. OS detection from the internet on a firewalled network is difficult. It's not difficult technically. It's difficult not just technically, but it's also conceptually difficult. So I'm going to give you a scenario. You have an Apache box that's protected by a firewall one running on Windows. Now, on a network level, if you look at that machine, even if you can do it, that thing is going to look like a Windows machine, right? Because it's running a firewall one on a Windows stack. But if you look on an application level, it's going to reply with the Apache banner. Now, which is it? Is it Apache or is it Windows? So it's difficult to actually determine what it is. Even if you can do it, technically it's difficult to understand which of the two it would be. So what we do is in BDBLA, we don't do OS detection. We just do banner scanning. And we don't do fancy banner scanning. We just do normal banner scanning. Because 99% of the people out there are not changing their banners, right? We do this asynchronously as well. And it's really nice to do it asynchronously. We do it asynchronously for a whole lot of ports. For the SSL stuff, we can do it asynchronously, but it's tricky. It becomes very tricky to do it asynchronously. What are we talking when we're saying asynchronously? Well, it's the same as the port scan. We're basically sending a SYN, right? And then we have a sniffer, which says if the source port is correct, it basically breaks into 3 trees. Normally, if you send a SYN, you're going to get a SYN ACK back. So this is the most likely. Okay, if the port is open, of course. Okay, this is most likely to happen. We get a SYN ACK coming back. Okay, we send an ACK because we have to, right? And if it's port 80 that we're looking for, we send a get/HTTP 1.0, right? If it's an ACK coming back, so that's either the response on this get/HTTP 1.0, or it's a banner like a 25 or a 21 or something like that. Okay, then we basically say, is it a port 80? If it's port 80 coming back, we have to extract the banner from the HTTP header. Otherwise, we simply just extract the banner from the ACK coming back to us. And the thing here to remember is with web servers is you need to send back that web server, because you're doing HTTP 1.0 is closing connection with the FIN, right? So if you don't ACK that FIN, right, that thing is going to keep on sending FINs for a long, long time, and we don't want to do that. So we have another tree that says, if it's a FIN, send a FIN ACK and close the connection nicely. Okay, and we do the same. This would also apply for the other banners, of course. Okay, so we can do with this thing on non-HTTPS banners, we can do 2,000 banners in 3 minutes. Okay, we can do it as quick as we want. So I'm going to show you here on the Sensepost network. I'm going to show you how we can get the banners really quick. So where's my video? Okay, there we go. Okay, so that's the port scan. I basically go to the banners. I import that in here. All right, bind my driver. Okay, it's bound. Select the interface where I want to send it out. And it starts off by doing multi-threaded HTTPS scanning, right? So that's not that fast. We're doing about 15 threads at a time. As you can see, it's not that fast. But you'll see that the stuff is coming down just now as the first stuff. Okay, so there's the stuff coming down. Now what I've done here is you'll see there's additional wait and there's a delay between packets. That additional wait is for those pesky little SMTP servers that, you're telling it to at port 25, it says, okay, open connection, nothing happens. And then, you have coffee and you have a smoke, and when you come back, the banner comes back, right? So we've got to wait a little bit of time for those things to come back to us as well. And that's the delay that we have over there, the additional wait delay. This is the delay between packets, the SYNs that we're sending out. Yes?
I got a question about this asynchronous banner requirement.
Okay. No. I basically wrote, well, I didn't write my own stack, but I wrote small little pieces of it, yeah. Sorry, the question was, did I write my own stack, or did I make a new connection when I, get the syntax coming back? And the answer is, I didn't write my own stack, but I also, I wrote small little pieces of it. Okay, it's not the whole stack, please. People that write stacks, you go like this. Okay. Yeah, if it comes back in fragmented IP packets, we screwed, but it usually doesn't. That's that exception thing, that 99.99% thing. So what you will see here is I'm going to drop this delay. As I'm doing this, I'm going to drop the delay down. In fact, when I saw this, when I was doing the video, I saw, yes, I have to do it really quick. So I dropped it down all the way to 2 milliseconds between packets. Now, the only way you can see it coming really quick in is here at the right-hand side, as soon as this thing, becomes a scroll bar. So let's just see what it looks like. Okay, so there the stuff is, that's still the SSL stuff coming in. And there's the other stuff coming in now, the normal banners. And I'm dropping it down there, you can see. And I see I'm not going to make it in time. So I drop it down to 2, and there's everything, right? There's the whole thing. What's interesting about this is you can also see that I'm now in that delay that I'm waiting for. What's interesting here is if you look at this, you see that it says there forcefully closed. So if we get a reset packet coming back, we can know that the port is wrapped, right? Because it got the syntax, and then after a while we get the reset. When we get the reset, we say, hey, this thing is wrapped. There's it sorted unique. You can look at all the banners coming back. We can do it really quick. Okay, you get the idea. I don't have to go through this more. Right, so that's what we do for fingerprinting. Call it fingerprinting. It's really not. It's just banner grabbing, right? Okay, the problem that we have now is we sit with a lot of targets, potential targets. And what we want to be able to do is we want to be able to say, I only want to look at this block, or I only want to look at this port, or and so forth and so on. So we build a kind of a targeting system in here that allows you to basically select parts of targets based on service banners, based on DNS names, based on port that's open, based on networks, a whole lot of different things. So you'll see I'm going to go to the targeting. I'm going to just update that tree. And there you see the blocks that we have. When you click on the blocks, you see the things that are either IP numbers, it's all IP numbers. You see IP numbers that either have DNS information, like a forward or a reverse, or that has a port open, right? And also you can see that, for instance, is a name server for a particular domain. And that one there, because it's in green, you can see that it's the MX record. You can go to the ports, and you can look at the ports. When you've done a banner scan, it would obviously also show you the banner for that particular thing. And in there, we can then start selecting targets, right? Okay, I know, we all see. Right, let's collapse that whole tree there. Okay, and we can basically say, okay, search for me on OpenSSL, right? And immediately, we get all the machines that have OpenSSL, it doesn't matter where. We can then say, make those things targets by just saying, selected is targets, and we get the IP numbers of all the banners or all the machines that's running OpenSSL. We can change it, and we can say, okay, we want to look for machines that are open on port 22. We do a search on that, right? We get all the machines that has SSH open, and we can say, I want to make all of those targets. See all of those machines. Those are, I suspect those are not all our machines. Kind of, Right. Okay, so what's next? Right, we've got our targets. Remember, we went from our domains, subdomains, we went forward, we did net block definition, reverse, we did vitality scan, we did banner scanning. What's next? We want to do vulnerability scanning, right? So with vulnerability scanning I'm not going to write my own vulnerability scanner. That's nonsense. I'm not going to reinvent the wheel. I'm going to look for something that's solid and widely used, and we all know that is Nessus, right? So we wrote a Nessus client that integrates with this thing. And basically how it works is it gives you the ability to select certain plugins. You can select one plugin as a plugin set, or you can select 10 plugins, or you can select all the plugins as a plugin set, and then you can scan it against those targets. So this is basically just the thing, and this is flaky, but you can have this thing that, that you can select your plugins that you want to run, and when you're done with that, you can save it as a PLG, which is a plugin set. Of course, everybody knows that PLG is a plugin set. Okay? Once we have the plugins selected that we want to use, right, we're going to the net blocks, we're going to the reverses. That's now on Sensepost. We've done the reverses in this case, so you can look at the reverses there. We've done the port scan, we've done the banner scan, and what we want to do is we want to do target selection now on the Sensepost network, right? So I'm going to update the tree. I'm going to go in there. I want to say everything that's got an open port within that range that we've decided has an open port through our port scan, those things are now going to be a target. So we can do it manually, or we can just go to the top of the tree, right-click, and say everything that has an open port in this node, make it a target. And immediately you get a list of IP addresses. Those are machines that are basically alive on that network. Those are the machines that we want to do vulnerability scans against. So I'm going to go to Nessus. I'm going to say import from app. Again, we get the targets from there. We update our plugin sets. We select which plugin set we want to use. This one, it's the Black Hat demo one. And we basically start it off. Okay, it's now connected to a Nessus server. It's configurable. It's getting the plugin list. It's annoying. NTP 1.0 don't allow you to, and 1.2 don't allow you to just specify the targets and the plugins. You first have to get the entire plugin list. WX, Nessus WX does this as well. That's that delay that you see. Okay, it's annoying. And basically, it's now doing a Nessus scan. It's basically doing a Nessus scan here. It's busy with the port scan. At any time, you can click this update tree button, and it will give you the results thus far. So far, we only had the port scans in there, so we only see the port scans. But this thing is running, and you can see exactly how many of the scans it still need to do, and so forth and so on. Right, I think I paused it here because I was, it's a little bit boring. Yes, okay. Okay, this was done from internal, by the way. Okay, so those ports, you won't see them from external. Okay, and you can see now some of them are already done in here. And if I click on it, I basically get nicely, formatted results. I can click on that, get an idea of what's it about. I can see on what port it was running, and all of that. So it's basically a Nessus client for this, but it's integrated nicely into this. Okay, so I'm going to just go on with this. Right, so we've done vulnerability discovery. The only thing left to do is to do vulnerability exploitation. And again, I'm not going to use my own vulnerability launching platform here. We are going to look at something that exists, and what's the nicest, widely used exploitation framework out there is Metasploit, right? So basically, the problem that we now have to do is we have to find out which machines that we scanned would be susceptible to exploits that we have in Metasploit, right? We have to tie these two together somehow. And the problem with Metasploit is some of the exploits in Metasploit is really, really operating system specific, right? So they say in this operating system it will work against NT Service Pack 3 language pack North Korean. Right? We don't have that information. We don't have it, and we can't get it over the internet. So what we do is we don't specify the target, right? And we hope for the best. And a lot of the Metasploit exploits actually does a brute force for that stuff. Okay, so it would go through all of them, and it's not such a big problem. The tie-in between the two is a little bit more difficult. What we need to do, what we actually did, or what Gareth Phillips, where's Gareth Phillips? There's he, Gareth Phillips, Sensepost, did for a week, is he basically sat down and he looked at every exploit that sits within the Metasploit framework, and he tried to match that back to entries, Nessus ID entries, right? And we got that list. And we're not going to keep on updating that list, because hopefully we can speak to the Metasploit guys, and when they write a new exploit, they can put the Nessus ID somewhere as a parameter within there, so that we can just scan it again and again and get the new Nessus IDs. I don't know if that's going to happen. We'll hope for the best. So the idea is we use Nessus to identify the weakness and Metasploit to exploit the weakness. It's easy. The R host, the SSL, the S host The R port, all of this stuff is known to us. We got it from previous steps, right? We know what port that particular thing is running on. Even if your website is running on a non-standard port, Nessus will identify it as this is a web server running on port 26. And so we can take that port 26 and patch it back into the actual Metasploit stuff. So let's see how this works, okay? Oops. Okay, I put a target in there. At this stage, it's a VMware server that we have. Okay, put the target in there. What I'm basically doing here, and this is important, I'm not going to scan for all the Nessus IDs, right? If I want to take the box, why don't I just scan for the Nessus IDs that I know have corresponding Metasploit plugins? So I've got a list of about, how much is it, Gareth? 120? 120 different Nessus IDs that I scan for. And that's all I need to scan for if I want to take the box. In this case, this is an old version, still had 90 in there. So I'm basically scanning now in real time that machine for 90 different problems. I found 3 on there. And you can see those are all red, except the last one. That's a coloration problem on the screen. It should be red as well. Okay? And we found 3 different problems that's kind of hectic on that machine. Hectic, I said it. I said hectic, see? Okay? Basically, we're going to go to Metasploit. I'm going to click on that link, that button over there, sorry, that button over here. Basically loads the Metasploit to Nessus definitions, right? Once I have that, I can basically click on the button over here that says Find Matching Targets. And what it will do now is we'll go through the whole Nessus scan and look for those IDs that I know is corresponding to Metasploit plugins, and say I can run this particular exploit against that machine, right? We got that. We have all of that information. All I need to do now is I need to select the payload that I want to use. So that basically, when I click on the Load Exploits button, it loads all the exploits that we have from Metasploit, gives you a kind of a description of the particular exploit, right? And all I need to do is I need to configure the payloads. Now the payloads need to be configured dynamically. So when I click on it, it basically does the actual call to Metasploit. It says these are the available payloads. I just missed it. I said there to do a reverse shell back to me, right? I don't know if you've seen that. Reverse shell back to me. And now I just have to set up the rest. But most of the stuff I know, right? Most of the stuff is set to auto because I know the R host and I know the R port that I'm going to run it against. So there's the actual VMware server. Just so you know, it's a VMware server, you know. And I'm going to start the Metasploit framework web interface on my machine. Now, that interface could be running anywhere, right? Could be running at the other side of the world. We fire that thing up. It's at this stage sitting on localhost. And now all we need to do is click on Start. And it's now running against that box, right? And it's running. And it's done. So if we open up in a web browser now the Metasploit framework, then hopefully when we go to sessions, we'll have our shells. And indeed, we have our shells, right? There's the shell sitting there. I can basically just go to it, click on it, and get the shell. Now, what you need to keep in mind here is this is one machine, right? One machine that we scanned. You have to see the whole picture, right? Domain, subdomain, so forth and so on. And we can have literally thousands of targets that's sitting in there. Okay, I'm going to go on. So are we done? Are we done? In a perfect world, we're done, but we're not living in a perfect world. So we know that Nessus is giving us false positives, and we know that we have to write those reports, right? Because we have to write reports. And what I've done is basically saying, let's look at a way that we can do this easily. Okay, that's just the configuration screen. I'll give you the ability to basically mark things as false positives, right? So there's a trace route that I want to mark as a false positive. I can just click on it, so it's a false positive. And if I see it again, I can say, well, mark this as a false positive everywhere, because clearly I'm not interested in this. Anyone that's done kind of assessment would appreciate this, right? Yes. Okay. And I can even put comments on stuff and say, well, this thing, it's an internal scan, so we don't actually care too much about that. Yes. All right. And what's interesting is these comments and even these Nessus vulnerability strings that we're getting, we now have the ability to, within the targeting system, search for that, right? And base our targets on vulnerabilities that we found. So if we go to the, go to the targeting, okay, we can now say, well, let's do, you see the Nessus stuff is now obviously also nicely integrated in there. We can see the comments, and what we can do is we can say, let's search for something. Come on. That's the problem of not, doing it live, not doing it live. I can say, let's search for SSH, right? Search again for that. And now I also get it where the Nessus server is complaining about something within SSH because it's simply a search function. And then I can take all of those things and I can make them targets. So immediately I know that those are issues, those are machines that possibly have issues with SSH, or that has a banner with SSH in there. If it's a specific Nessus vulnerability, I could put that string in there and say, only search for machines with this particular vulnerability that Nessus identified, right? I can do reporting in terms of saying, the reporting looks like this. I'm quite proud of this. It's like a Microsoft thing. Check it out. Yeah? It does it in Word. Okay, it does some word automation. It basically builds up these host tables for you that says, this is the forward, this is the reverse, where does this thing sit, what ports are open, what's the banners, what's all the Nessus problems that we found on it. And I know you can't see the other side, so I kind of made it smaller. There we go. Okay, and even the comments that we put in there, we can have the comments nicely defined. Go, yes. You can see it all. You can now go down. Go down. You can see the analyst comment in there saying, it's supposed to be one. So all of the comments and the stuff that we put in there is preserved. And these things, if you've done assessments, you will know why this is nice, right? Because you spend a lot of time doing exactly this. Okay. So the last thing I want to show you quickly is the we did the footprint. Remember, we did the footprint on IBM. So I'm just going to load the IBM stuff quick. Okay. Those are the blocks. Yeah, check those blocks. Did you see those blocks? They are massive. There's some heavy class Bs in there, right? And we can say do a report on the footprint. And it will basically, you can even do reports on banners and that. I'm not going to show you all of that. Basically, we'll sort, this thing is now sorted by subdomain. So you can see all of the subdomains and where the IPs live and, entries for them, reverse, are they forward, are they reverses, all of that stuff. I think you get the idea, right? So we do a lot of reporting for you. Because at the end of the day, reporting is part of doing an assessment, and the talk is about, can we automate assessments, right? Right, so what's the bottom line? Billy Blah does 80% of the work. Within 20% of the time, it takes us to do it manually. This means, and the last 20% of the work almost always takes 80% of the times. This gives us the ability as assessment, as analysts, or call it pen testers, call it whatever you want, to spend our time on the stuff that we actually need to spend our time on, which is not, copy and pasting stuff out of Nessus reports. We don't want to spend our time doing that. We want to spend our time on the more interesting things, the things that add more value to the client, right? The bottom line, some steps in the methodology, really hard to automate. And it's usually when things go non-standard, like when it's, exceptions on the rules. You would also find that there's a lot of pen testing companies out there that would hand in a report that this thing generates as their final report and say, that's it. So hopefully this thing will kind of lift the bar, raise the bar a little bit on mediocre. And I'm not saying all pen testing companies are mediocre, but on mediocre pen testing companies. On the release considerations of this tool, we have a problem. The first part of this side of the class is saying, you're not going to release this thing, right? I mean, come on, you're giving a script kiddie a tool that it can click, 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 and and he's got a shell on all my machines that can possibly have shells on. And you got this side of the class that says, where's the URL? Where can I download it? So it's a kind of a thing like this. So what we've done is we've got a crippleware version that has a 20-minute runtime and that you can't save stuff on the website at www.sensepost.com /bdblah. The last thing I want to tell you, don't forget about the EOR release. It's a nice web application assessment tool /research/EOR. And is there any questions? 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 No questions? There's a question. Frank, take it away.
On your asynchronous scan, you're sending out a SIM up through like a net firewall. How does the firewall response drop the response?
Okay, so what he's saying is, so what Frank is saying with the asynchronous banner scanning, what's happening is we're sending out SINs, right? And our stack does not know about those SINs that we're sending out. So when the SYNAC comes back, how does it come into the stack? Why is it not, why is it not blocked by the firewall? One of the things that you need to do is you need to remove your firewall, right, when you run this thing, so that those packets can your personal firewall needs to come back into your machine. The other consideration there is if you're grabbing the banner, right, you're sending out a SYN, okay? And there's a SYNAC coming back to you. Your stack also doesn't know about this, so it replies with a reset. It says, no, I don't know anything about the SYNAC, so it sends back a reset. So what you also need to do is you need to somehow block those resets from coming out. You can do it in two ways. You can either do it upstream at a firewall, or you can do it again with a firewall that's running on your machine itself. For this, we use WIPFW, which is a Windows implementation of the famous BSD IPFW, and it's one rule that you install there, and that's it. Then everything is good. There was a question there? No? He left? There's going? No? Yes?
Is there a way to, rather than having SS rerun port scans, which it doesn't do probably really as well as the asynchronous port scan does, to kind of, you've already done a port scan against this host, presumably, you can import that data?
Oh, absolutely. That's the thing that's nice about this. What I can do is I can show you the tool live, kind of live. We got data in there from Electronic Arts, but they kind of gave us permission to, show what it is that we're going to show. So I'm just going to flip to that. Okay, so this is actually the information that we gained for their stuff. There's the subdomains. There's all the forwards. That's crazy. I mean, look at this, no? And look at all these domains. They got like alpha.pogocorp.com. It's hectic. They've got lots of stuff. The net blocks, I've trimmed it down a bit, but those are all the class C's that they got in their class B. You can check it. It's quite crazy, right? And to answer your question, okay, this is the reverses, right? There's the reverses. There's the port scanner. What you can do, you've done the port scan, right? You want to get the port scan information from somewhere else. So all you need to do is you need to get it in this format, right? Which you can sed, awk, whatever. And then you can paste it in here. Right? Then this is just the text field. Oh, it's not a 0, it's an O for open. You can set here, sorry, at the setup, you can set it here to show closed ports as well. Okay, then it would show X for closed. This is the open and the closed ports. Okay, and you can see the banners. Look at these banners. Yes, lots of banners, right? Targeting, there we go. These are targets within all those pieces of class C's. Lots of targets. And yeah,
So now you're going to say you're on the Nessus scan.
Hello?
If you're going to run a Nessus scan now against your targets?
I can, if I want to, yeah. I can also import the targets right there. Sorry, am I missing the point? What's the point?
Can you take the port scan to Nessus, so Nessus doesn't have to do the port scan again, because Nessus is doing it slower than you are.
Oh, I see. Okay. No, but you see what you can do is just don't enable the port scans on Nessus.
And it'll get from your port scan operating system.
Well, if you have dependencies enabled, right, it will check if the port is open. Am I right? It will check if the port is open. It will check if the port is open, then the run thing. So you don't have to do the port scan. Absolutely, no, you don't have to. You just say, I don't want to do that. In the Metasploit stuff that we ran, we didn't port scan, right? You saw it was only 90 and went like this because it wasn't doing the port scan. I mean, the power of this thing really comes in if you want to do a situation where you say, I want to test my whole network for, let's say, mail relaying, right? So you go get the whole thing, say, I want to get I want to test for port 25, right? Zip, there you go. It takes you, 2 minutes per class B. You run one plugin within Nessus, and you run it across all of the targets that you found. So, I mean, you can literally, within half a day, find all the open relays. The other thing that this is interesting for, from an attacker's perspective, okay, and I'm not supposed to be saying that too loud, but, you know, if you have O-Day, right, you can pre-target everything that you want to attack. You just need to load it then within Metasploit, which is kind of nice to write exploits in, and execute it. And you do pre-targeting. You know exactly what's the machines out there. You know where the network lives. You can be doing this from anywhere for months, collecting information. And if you really want to launch it then, I'll give you a platform even to launch it from. But like I said, I wouldn't be saying that actually. So, I mean, you know, but you can think, you can think what you can do with it. Just like I said, the one guy's assessment is another guy's attack. So, okay, I thank you for your time. Thanks.